Hey Ivan, this is Dr. Sweeney. I got some of your questions, and so I'm going to see if I can answer some of them and then throw you up some videos in order to kind of help you out. I don't know if I can't guarantee that I can always do this. It depends upon what students I have actually inside of the Academic Computing Center. But yeah, so I'll do as much as I can. One thing that I should ask you is if you could tell me what you've done, or maybe even screenshot something that you've actually done as you've started, right? That will help me out to kind of point out some places where I might actually be able to help you even more. All right, so let's take a look at number 15. And so 15 is asking us, it's saying differentiate, all right, f of theta equal to theta cosine theta sine theta, okay? So what I want to notice here is that I've actually got three functions. All right, I've got theta is one of the functions. I have cosine theta as a second function, and I have sine theta, which is the third function. So since I'm multiplying three functions together, I'm going to use the product rule. All right, and just to kind of show some things out, let's call g of theta equal to theta is one of our functions. We'll call h of theta equal to cosine theta is the second function, and we'll call m of theta equal to sine theta is our third function. All right. So if you remember the product rule, what we're going to do is we're going to like basically piecewise. We're going to take the we're going to basically we'll take the derivative of the with respect to theta of g of theta theta, which is 1. Okay, so g prime of theta with respect to theta is going to equal 1. So that's going to leave me with, so my f prime of theta is going to start out, it's going to be cosine theta, right? Sine theta, because it's going to be 1 times cosine theta sine theta. Then we're going to add to that the derivative of cosine theta sine theta times theta. So it's going to be theta, right, times, now the derivative of cosine theta sine theta, all right, is going to be first the derivative of cosine theta times sine theta. So we have h prime of theta is going to equal negative sine theta, okay? And m prime of theta is going to equal cosine theta, okay? So first, right, I've got that theta, that's my original value, and then I'm going to multiply that by, negative sine theta times sine theta, and then I'm going to add to that, okay, cosine theta, because that's the derivative of sine theta times cosine theta. All right, and there we are, okay? So this is now going to equal cosine theta sine theta plus, or actually in this case minus, theta sine squared theta plus theta cosine squared theta. All right, and that's it. That's f prime of theta. All right, so notice what I did was I actually did here, this is, right, this thing is the product rule for cosine theta sine theta. All right, so I started out, I basically broke it up into pieces. I said, all right, first I'm going to take the derivative with respect to theta and then multiply that by this function, cosine theta sine theta. And then I'm going to take theta, right, okay, the non-derivative, so it's just the function itself, and multiply it by the derivative of cosine theta sine theta. And then to find the derivative of cosine theta sine theta, I had to do that one step at a time, okay? And so that actually is your number 15. Okay. There might be a little bit more simplification in there. I'm not thinking through in terms of cosine squared theta minus sine squared theta might be something else. I can't think of it off the top of my head. So you might have to do a little bit more adjustment. All right. Next up is this one 37 that you had. Okay. And so what 37 stated was you had a graph, right? Okay. Where this was 10. So this is your ladder, right? Okay. And then x is the distance away from the wall. And then theta, okay, is the angle. And what they wanted to know is what is the derivative? Let me actually just make sure that this is the case. It says, and let x be the distance from the bottom of the ladder to the wall. If the bottom of the ladder slides away from the wall, how fast does x change with respect to theta when theta equals pi over 3? Okay, gotcha. Great. So, okay, we want to know when theta equals pi over 3, what is dx d theta? Okay, right? Yep, dx d theta. How fast does theta change? Fast does x change? Okay, with respect to theta. So, all right, what I'm going to do is I'm going to set up an equation. Notice that this, with respect to the theta, x. Oh, actually, let me just make sure also that that's the case. Who knows? The top of the ladder on the wall. Golly, love it. Why, who would ever think the other way around, right? It's actually not that. I went back and I reread it because, right? So here's theta. Okay, there's theta. And so we got theta x, right? That's actually where theta is going to be. So if I rewrite this, what this is going to be is that notice it's x is opposite theta. So this is going to be the opposite over the hypotenuse. So sine of theta, okay, is going to equal x over 10. And that means that x equals 10 sine theta. Notice that all I did was I just multiplied both sides by 10. And the reason why this is so important is because this now gives me, this is x is a function of theta. So x is a function of theta. So consequently, right, we get dx d theta is going to be the derivative of 10 sine theta. So dx d theta is going to equal 10 cosine theta. Great, 10 cosine theta. And then what we'll do is, okay, so we're going to determine dx d theta at pi over 3. And so that's going to equal 10 cosine pi over 3. Okay, now cosine of pi over 3 is, right, okay, it's going to be that value right there. So it's 1/2. So it's 10 times 1/2, which equals 5. So that is the change, how fast the ladder is changing with respect to the change in theta when theta is equal to pi over 3. Okay, cool. Next up, 47. Now, these two, I'm pretty sure, and I didn't have my book with me. Unfortunately, it's sitting at school right now. But I believe that probably what you're going to use for these is you're going to use L'Hopital's. So it's like find the limit. And so we'll use L'Hopital's, okay, because that's what you use if you are um, using derivatives in order to find limits. Now we're going to talk about like when do you know exactly that you're going to be doing that. But let's start out with 47. So 47 said had the limit as pi approaches 0 of cosine, excuse me, not pi approaches 0, as theta approaches 0. Of cosine theta minus 1 over 2 theta. All right. And so what I know is that if I plug in as theta approaches 0, excuse me, when I plug in 0, I get cosine 0 minus 1 over 2 times 0, which ends up being 0 over 0. Okay, so it's undefined, but it's an undefined in a way in which I can actually use L'Hopital's. So I'm going to use L'Hopital's. And what you want to remember if you're using L'Hopital's is you want to remember, okay, that we take the derivative of the top and the bottom, and the derivative of the top of the bottom, evaluated as theta approaches 0, is going to be my my limit, okay? Assuming that it doesn't end up with an already undefined value. So notice 0 over 0 is the right kind of undefined. 1 over 0, not the right kind of undefined, okay? But 0 over 0 works. So we'll take first, okay, the derivative, and I'm going to write it like this, cosine theta prime, and that's going to then equal negative sine theta, right? Because we're just going to take the derivative of cosine theta, and then the derivative of negative 1 is just negative 1, all right? Then we take the derivative of 2 theta, right? And that just equals 2. So after taking those derivatives, our limit as theta approaches 0 is going to end up being negative sine theta over 2. And this is now going to equal negative 0 over 2, which is equal to 0. And so that is, in fact, our limit. Okay? So we're going to use L'Hopital's, and using L'Hopital's means taking the derivative of the top and the bottom, right, until you end up with a non-undefined value. 0 is totally defined. It's not a problem. Our bottom is 2. 0 over 2 is 0. So consequently, that ends up being our limit. Okay? Let's take a look at number 49, because 49 also uses L'Hopital's as well. So we've got the limit as x approaches pi over 4 of 1 minus tan x over sine x minus cosine x. Okay? Now, what I'm going to notice is if I take, so note, 1 minus tan of pi over 4 divided by sine pi over 4 minus cosine pi over 4 is simply equal to 0 over 0. So again, we have an undefined, right? Undefined. So given the fact that it's undefined, okay, what that means is that I'll use L'Hopital's. That it's defined this, undefined this way, 0 over 0. There's other ones, 0 to the 0th power, right? Infinity times infinity, right? Infinity over infinity. Those are going to be forms that we can use L'Hopital's with. So we're going to use L'Hopital's rule. And so I'm going to take the derivative of 1 minus tan x, okay, prime. Please don't. So the derivative of 1 minus tan x is going to equal just negative secant squared x, right? And then the derivative of sine x minus cosine x, okay, is going to equal cosine x minus negative sine x, right? So we're going to get the limit as x approaches pi over 4 of negative secant squared x divided by cosine x plus sine x. Okay? Now, secant squared x, or negative secant squared x, is going to be, okay, it's going to be negative, and this is going to be 1 over cosine pi over 4 squared, okay? And then this one is going to be cosine pi over 4 plus sine pi over 4. Now, remember that cosine pi over 4 is root 2 over 2. So this is going to end up equaling negative root 2 over 2 squared divided by, and this will be root 2 over 2 plus root 2 over 2. Okay? And so this is then going to equal 2 over 4 divided by 2 root 2 over 2. Okay? By the way, okay, so, yeah, there we go. That's the limit as pi, as x goes to pi over 4. And so what we end up with here now is going to be 2 over 4 times, and this will be 2 over 2 root 2. So this is just a fraction. You're dividing 2/4 by 2 root 2 over 2. So consequently, you're just going to multiply by the reciprocal. And so consequently, this is going to be 2. It's going to be a 1, this will be a 1, this will be a 1. So this is going to end up equaling 1 over 2 root 2. And then probably, if you're looking at your answers in the back, whatever, we're going to rationalize the denominator. So this is going to then be 1 over 2 root 2 times root 2 over root 2. So this equals root 2 over 2 times 2, which equals root 2 over 4. And that's your answer. Okay. I should state this. I'm kind of like, doing this on the fly. I want to make sure that, you get a video so you can actually see what it is that we're doing. I'm going to try my best to make sure that all the math is right. The process is 100% right. Okay. Like, I have no doubts that I know exactly what I'm doing, right? But as I work and talk at the same time, sometimes, I make like 2 times 2 equal to 2. So just be careful about that. I don't think it's the problem here. I'm going to check it right now, but I wanted you to be aware of that might be something that does occur occasionally. Okay? See? Already happened. Already found it. Okay. So this is actually, it's 1 told you. This is 1 over cosine pi over 4. Well, cosine pi over 4 is root 2 over 2. Okay? That means that the 1 over root 2 over 2 is 2 over root 2 squared. Okay? Which is equal to, okay, have that, is going to equal 4 over 2. Great. Okay? So this is then going to give me 2 times 2 over 2 root 2, which equals 2 over root 2. And then rationalize the denominator, I end up with times root 2 over 2 root 2 equals 2 root 2 over 2, which equals root 2. Yay. Sorry about that. Like I said, just be careful. And it's negative. Ugh. Okay. Negative, 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 or not negative, that's not negative. Yes, that is negative, excuse me, negative. And then finally, so it's going to be negative root 2 over 2. All right. So hopefully you understand what we are, what's trying to happen here. Big point here with these L'Hopital ones is we're going to take, it's going to be 0 over 0, okay? Whenever we have something of this form, that means that I can use L'Hopitals in order to actually go and solve for the limit, right? And how I do that is I take the derivative of the top divided by the derivative of the bottom, right? And then evaluate that as x approaches the same limit, right? In this case, I took the one derivative and I ended up with what I needed, okay? All right, I hope that helps you out. I'm glad that I got a chance to do it. Like I said before, if there are nobody inside of my tutoring rooms, then I will go and answer questions.